we are going to study about the iron carbon equilibrium diagram. This diagram is very helpful for metallurgical study because iron is one of the important metal that is used by the engineers, and iron having some of the difficulty that they have the low property, that is the strength and ductility. Second, it easily rust during the atmosphere condition. To convert the iron into the iron alloy, we are adding the carbon and making the steel and cast iron. This, by studying this diagram, iron carbon diagram, we are getting the different phases of the steel and cast iron. Now this diagram here is drawn here by taking the composition, that is the iron. We are adding the carbon in the iron, that will form the iron carbide. So starting from the 0, that is the 100% iron, and we are adding the carbon here. Okay, that is the 1, 2, 3, 4, 5, 6%. Okay, up to the 6.67% only. Why? Because after the 6.67%, the material, that is the carbide, is formed, and that is very hard, and that cannot be used further in engineering application. Okay, due to the high brittleness, there are different phases of the iron and carbon that is produced here in the iron carbon diagram here. Now this is the figure here, okay, that have the different here the temperature. We are getting the different here the alloy here. Okay. So we are getting the first here. Okay, if you add here the carbon percentage, you see this one, the carbon percentage up to the 0.08%. We are getting the alpha ferrite. That is the one of the alloy of the carbon in the steel. The second one, we are getting the austenite. Okay. Austenite getting here above the 723 degrees centigrade up to the here the up to the 1130 degrees centigrade, and after that one we are getting the delta ferrite, the carbon that having up to the 2%, that is called the steel, and above the 2% we are getting the cast iron. The ferrite is one of the constituent, that is alloy here, perlite here, that will obtain here when we are composition at the alloy of the iron and carbon is slowly cooled here below the 720 degrees centigrade. We are getting here the perlite here. Okay, that is the combination of alpha ferrite and cementite. Then we are getting the above this one 0.8% of the carbon, we are getting the perlite and the cementite here. Okay. And after this one, the higher here the percentage of the carbon, okay, we are getting only the carbide formation like this. So there are three invariant reactions take place in the iron carbon diagram. First here the reaction, that is the eutectoid reaction. Eutectoid reaction that takes place at the temperature of 723 degrees centigrade and carbon percentage 0.08% of carbon. In this phase here, okay, there is the formation of perlite. The second here reaction that takes place here, that is called the eutectoid reaction, that will take place at the temperature of 1130 degrees centigrade. In this way, we are getting this one, the austenite formation. And the third reaction, that will be the eutectoid reaction, in which the delta ferrite that will produce here, okay, that after the cooling, we are getting the gamma austenite. Now, we are going to learn about the cooling curve of the pure iron, definition of the structure, what are the different structure of the iron here, iron carbon equilibrium phase diagram, iron carbon carbide diagram, austenite to ferrite transformation, nucleation and growth of the perlite here, effect of the percentage carbon percentage on the microstructure of the steel, relation between the carbon percentage and mechanical property of the steel. Now, the metal iron is the primary constituent of the most of the ferrous alloy to form the steel and the cast iron. Okay. The pure iron here used for the very limited application. Okay. That is the used for the air drainage, culvert, refrigerator cabinet, washing machine, roofing, and where we require the load train and the load here the elongation. The tensile train up to the 279 Newton per mm square, elongation okay, up to the 40% and optimal hardness we are using 30% for the pure iron. Now this is the equilibrium curve for the pure iron. When we are going to heat this one at the different temperature, we are getting the different product here. Alpha ferrite that is available up to the 70 degrees centigrade. And after that one, it will convert into the austenite. In between that one, this ferrite structure having the BCC structure, that is the high train and some of the elongation there. Then it will convert into the gamma ferrite, that is the kind of the gamma iron that is available for the temperature of the 910 degrees centigrade to the 1400 degrees centigrade. And after that, if we hit this one, we get the gamma ferrite, and that again there is the change of the structure from the FCC structure to the BCC structure here. And after this melting temperature, that is the 23 degrees centigrade, we are getting the liquid iron. So there are the deep water here. The first there is the alpha phase having the BCC structure. After that one, there is a conversion of the phase from the BCC structure to the FCC, that is the gamma ferrite, and then after that one we are getting the here the austenite phase conversion and then the delta phase conversion. Okay, there are different phases that occurs here when we are adding the carbon in the iron here: austenite, ferrite, perlite, cementite, martensite, and the ledeburite. So these are the different here the structure of this one. The austenite structure that having the FC structure, ferrite and the delta ferrite and delta here we are having the BCC structure. Okay. Depend upon structure, the molecule that is arranged here, okay, the compact size here, the train and elongation is vary based on the structure of the constituent. Now see the microstructure. We are getting this microstructure of the austenite. The austenite having the structure like this one, that having the partition, okay, and that having the most of the cementite that will on the boundary, and the ferrite here inside this one, that is called the austenite structure. Perlite having there are the laminate structure that having the alternate the ferrite and the cementite structure, and the ferrite that having the whitish color and cementite in the blackish color. These are the microstructure that is observed here when we are look in the microscope structure. Okay, these are the other structures that will depend upon the microstructure, that is the which type of the lens we are using this one. Okay, we are getting the structure, that is the superiority of the structure depend upon the microscope, okay, and the lens here the magnification power. Okay. Now we are going to see one by one what is by the ferrite. Ferrite is the solid solution, okay, of the alpha iron. It is the international solid solution of a small amount of the carbon dissolved in the gamma iron, okay, and stable form up to the temperature at the 9, 10, 12 degrees centigrade. Okay. The maximum solubility is 0.025% of the carbon at 720 degrees centigrade, and it dissolve only 0.008% at the room temperature. It is the softest structure that appears on the diagram here. The second one, okay, the ferrite structure look like this one. The tensile 40,000 psi, elongation 40%, hardness, okay, that is the rocky hardness structure up to the 90. We are measuring with the help of the piece scale. Then the perlite, okay, this is the ecotite picture, that is formed in the ecotite reaction that containing the 0.8% carbon, and that is formed at 720 degree on very slow cooling. Okay, that is having the laminar picture of ferrite and the cementite here. Okay, the white ferrite diagram or matrix contains the three phases of the cementite. Dark one is the cementite, and the white one, okay, that is the ferrite structure. Then the perlite, okay, the perlite here that having the laminar structure, okay, that is, see this one, okay, that is the black and the white structure. Black is the cementite and the white is the perlite here. That is the improved in the hardness, okay, then also improved here as compared to the ferrite here. The perlite is having the higher strength and higher here the hardness. Then the next one, austenite, okay, that will obtain here at the temperature of this one above the 910 degree centigrade up to the 14,000 degree centigrade. Okay, and the maximum solubility of this carbon in the iron here, the 2% at the temperature of 11 degree centigrade. Okay,